Welcome to Let Us Crack GATE and ESE ME. This is K. Umamaheshwar Rao. This is the batch, Super Talent batch for GATE XE. Complete Mass XE covered by K. Umamaheshwar Rao, myself. Complete Technical Subjects by J.S. Gill. Detailed coverage of GATE XE syllabus along with handwritten notes, extra practice sheets. The tests are curated by J.S. Gill and Umamaheshwar. Myself, K. Umamaheshwar Rao, Faculty of Engineering Mathematics for GATE and ESE. Presently working as educator at Unacademy. I have 21 years of teaching experience, guided more than 1 lakh students. Unacademy is announcing Padho, Khelo Crack, karo. Land with top educators from July 1st to July 30th, Mechanical Engineering. Concept based learning for each subject. Take a quiz and check your preparation. Unacademy is announcing Lakshya batch for GATE 2023. Batch commences from July 2nd. Use code KUR75. Unacademy is announcing Pragati batch for GATE 2024. Batch commences from July 7th. Use code KUR75. Unacademy GATE and ESE Mechanical and Chemical branch get up to 4 months subscription free on your iconic subscription. Hurry, save up to 39% off last day offer. Use code KUR75. Benefits of 1:1 live mentorship program with Unacademy GATE and ESE iconic subscription. Schedule your session as per your convenience. Progress report available to monitor for tracking the learner activity, exam and preparation guidance. The features of Unacademy: top educators, doubt clearing sessions, study notes, test series, available for both iconic subscription and plus subscribers. 1:1 live mentorship program, physical notes, strategy and study program, live audio interactions during open house, available only for iconic subscribers. Nothing can stop you from chasing your GATE and ESE dream. Avail loan and no cost EMI for GATE and ESE. For more details, call 8585858585. Daily scholarship test is now available on Unacademy website. Log in with your number, click on start learning, select your goal, start the test. Unacademy is announcing Lakshya batch for GATE 2023. Batch commences from July 7th. Unacademy is announcing Pragati batch for GATE 2024. Batch commences from July 7th. Either for plus subscription or iconic subscription, use code KUR75. Now, in the previous session, I have discussed about types of matrices. Now, transpose of matrix and what is symmetric, what is skew symmetric, what is orthogonal matrix, conjugate of a matrix, transjugate of a matrix, Hermitian, skew Hermitian, unitary, then properties and determinant and its properties. First, transpose of a matrix. The transpose the transpose of a matrix A. Transpose of matrix A is denoted by A transpose and is obtained by interchanging rows into columns. The transpose of matrix A is denoted by A transpose and is obtained by interchanging rows into columns. For example, A is 2, 3, 7, 2, 6, 5, 3 rows, 2 columns. A transpose is with 2 rows and 3 columns. 2, 7, 6, 3, 2, 5. It is 2 cross 3 matrix. So if A is 3 cross 2, A transpose is 2 cross 3. Now, symmetric matrix. Symmetric matrix. When we say matrix is symmetric, a square matrix A square matrix A is said to be symmetric if A transpose equal to A, that is Aij equal to Aji for all ij. Understood? A square matrix A is said to be symmetric if A transpose equal to A, that is Aij equal to Aji for all ij. For example, matrix A is 1, 3, 5, 3, 9, 7, 5, 7, 6. 135, 135, 397, 397, 576, 576. A transpose equal to A. Therefore, it is symmetric matrix. Next one. Skew symmetric matrix. Skew symmetric matrix. When we say matrix is skew symmetric, a square matrix A is said to be skew symmetric if A transpose equal to minus A, that is Aij equal to minus AJI for all ij. Aij equal to minus AJI for all ij. For example, zero, 1, 2, 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. It is a skew symmetric matrix. Understood? Please remember, if the matrix is skew symmetric, always principal diagonal elements are 0. The principal diagonal elements of skew symmetric matrix are always 0. Next one, orthogonal matrix. A square matrix A is said to be an orthogonal matrix. A square matrix A is said to be an orthogonal matrix if A into A transpose equal to A transpose into A is equal to I. A square matrix A is said to be an orthogonal matrix if A into A transpose equal to A transpose into A is equal to I. Understood? Now, for example, A is 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3, minus 2 by 3, 2 by 3, minus 2 by 3, 1 by 3. That is an orthogonal matrix. Next one, conjugate of a matrix. What is conjugate of a matrix? Conjugate is an operation generally we use it to apply on complex numbers. If A plus IB is the given complex number, A minus IB is corresponding conjugate. So what is conjugate of a matrix? Every element of the matrix is replaced by corresponding conjugates. Then we will get conjugate of a matrix. The conjugate of a matrix A is denoted by A bar and is obtained by the conjugate of a matrix A is denoted by A bar and is obtained by replacing replacing every element of A by its corresponding conjugates. The conjugate of a matrix A is denoted by A bar and is obtained by replacing every element of A by corresponding conjugates. Observe, A, matrix A is 1 plus I, 2 minus 3I, 4I, 2. 1 plus I must be replaced by 1 minus I. 2 minus 3I must be replaced by 2 plus 3I. 4I must be replaced by minus 4I. 2 is 2. Every element of A must be replaced by corresponding conjugates. Then the resultant matrix is known as conjugate of original matrix. Next one, transigate of a matrix. The transpose of conjugate the transpose of conjugate of a matrix. The transpose of conjugate of a matrix is known as transigate of a matrix. The transpose of conjugate of a matrix is known as transigate of a matrix. It is denoted by A bar transpose or A power theta. A bar transpose or A power theta. Now, matrix A is 2, 1 minus I, 3 plus 2I. Then A bar is 2 is 2, 1 minus I must be replaced by 1 plus I must be replaced by minus I, 3 plus 2I must be replaced by 3 minus 2I. Next, A power theta is equal to A bar transpose. Just we have to transpose A bar. We have to transpose A bar 2, 1 plus I, minus I, 3 minus 2I. That is known as transigate of A. Based on transigate operation, we have again 3 classifications. A square matrix, A square matrix A is said to be number 1 Hermitian, A square matrix A is said to be Hermitian matrix if A power theta is equal to A power theta equal to A, that is Aij equal to Aj bar for all Ij. The square matrix A is said to be skew Hermitian. 1 minute. Hermitian. A power theta equal to A. Aij equal to Aj bar for all Ij. For example, A is 2, 1 plus 3i, 1 minus 3i, 4. Observe leading diagonal elements. Compulsory leading diagonal elements must be real. Okay, na? So Aij equal to Aj bar for all Ij, then the matrix is known as Hermitian matrix. Next one, skew Hermitian matrix. A square matrix A is said to be skew Hermitian matrix if A power theta equal to minus A, that is Aij equal to minus Aj bar for all Ij. For example, matrix A is principal diagonal elements are 0, 1 plus 3i minus 1 plus 3i, that is skew Hermitian matrix. Next one, unitary matrix. Third one, a square matrix A is said to be unitary matrix if A into A power theta is equal to A power theta into A is equal to I. A into A power theta equal to A power theta into A is equal to I. For example, matrix A is 1 plus I by 2, 1 plus I by 2, observe 1 plus I by 2, 1 plus I by 2, minus 1 plus I by 2, 1 minus I by 2. This is an unitary matrix. A square matrix A is said to be unitary if A into A power theta is equal to A power theta into A is equal to I. Next one, determinant of a square matrix. Determinant value of a square matrix. Determinant value of a square matrix. Now, the sum of the products of elements of a row or column with their corresponding cofactors, the sum of the products of elements of a row or column with their corresponding cofactors is known as determinant value of a square matrix. The sum of the products of elements of a row or column with their corresponding cofactors is known as determinant value of a square matrix. For example, suppose if the matrix is 2 cross 2, A, B, C, D, then determinant value of A is given by AD minus BC. Suppose if the matrix is 3 cross 3, one, 3, 5, 1, 1, 2, 2, 3, 7. Det A equal to 1 into 1, 2, 3, 7 minus 3 of 1, 2, 2, 7 plus 5 of 1, 1, 2, 3. Now 1 of 7 minus 6 minus 3 of 7 minus 4 plus 5 of 3 minus 2. 7 minus 6 is 1, 7 minus 4 is 3, 3 3 is 9, plus 5 into 1 is 5, that is 6 minus 9, that is minus 3, non-zero. If det A is non-zero, then the matrix is known as non-singular matrix. If det A is non-zero, then the matrix is known as non-singular matrix. If det A equal to 0, then the matrix is known as singular matrix. If determinant value of A is non-zero, then the matrix is non-singular. If determinant value of A is 0, then the matrix is singular. Next, properties of determinant. Determinant value of A and determinant value of A transpose are always same. Determinant value of A is equal to determinant value of A transpose. Determinant value of AB is equal to det A into det B. Determinant value of ABC equal to det A into det B into det C. Determinant value of A plus B is not necessarily, if determinant value of A plus B is not necessarily equal to det A plus det B. Determinant value of A plus B not necessarily equal to det A plus det B. The determinant value of A triangular or diagonal matrix is the product of its leading diagonal elements. The determinant value of a triangular matrix or a diagonal matrix is the product of its leading diagonal elements. If the matrix is triangular matrix or diagonal matrix, then its determinant value is given by product of its leading diagonal elements. 1, 2, 3, 0, 4, 5, 0, 0, 6. Now, det A is given by 1 of 24 minus 0 minus 2 of 0 minus 0 plus 3 of 0 minus 0. That is 24. So det A equal to 24. The value of determinant is 24. Next. In a square matrix, if two rows or two columns are identical or proportional. In a matrix, if two rows or two columns are identical or proportional, then the value of its determinant is 0. In a square matrix, if two rows are identical or proportional, then the value of its determinant is 0. For example, 2, 3, 5, 6, 9, 8, 6, 9, 8, 2, 3, 5, 6, 9, 8, 6, 9, 8. Now, 2 of 72 minus 72 minus 3 of 48 minus 48 plus 5 of 54 minus 54. Finally, the result is 0. In a square matrix, if two rows are identical or proportional, then the value of its determinant is 0. Next property. In a square matrix, in a square matrix if each element of a row or column is 0, if every element of a row or column is 0, then the value of its determinant is 0. In a square matrix, if every element of a row or column is 0, then the value of its determinant is 0. For example, 2, 3, 5, 6, 9, 8, 0, 0, 0. 2, 3, 5, 6, 9, 8, 0, 0, 0. Then clearly the value of det A is 0. The value of determinant is 0. Because every element of one row is 0 or one column is 0, then the value of its determinant is 0. Next point, the determinant value of A skew symmetric, the determinant value of a skew symmetric matrix of odd order, the determinant value of a skew symmetric matrix of odd order is always 0. The determinant value of skew symmetric matrix of odd order is always 0. 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. Therefore, det A is 0, minus 1 of 0 plus 6 plus 2 of 3 minus 0. That is 0 minus 6 plus 6. Finally 0. The value of determinant is 0. Because matrix is skew symmetric matrix of odd order. Next one. The determinant value of an orthogonal matrix, the determinant value of an orthogonal matrix is always either 1 or minus 1. The determinant value of an orthogonal matrix is always either 1 or minus 1. A matrix is said to be an orthogonal matrix if A into A transpose equal to I. A into A transpose equal to I. We have to prove that determinant value of A is either 1 or minus 1. That's why take determinant on both sides of this equation. Determinant of A into A transpose equal to determinant value of I. Det A into det A transpose equal to 1. Det A Determinant value of A transpose is det A. Det A into det A is equal to 1. Det A whole square is 1. From this we can write det A is either 1 or minus 1. The value of determinant is either 1 or minus 1 because A is an orthogonal matrix. So the determinant value of an orthogonal matrix is always either 1 or minus 1. Next property. If A is a square matrix, A is a square matrix of order n and K is any scalar, then if A is any square matrix of order n and K is any scalar, then determinant value of Ka equal to K power n into det A. Determinant value of Ka equal to K power n into det A. Next one. If A is a non-singular, matrix, if A is a non-singular matrix of order n, if A is a non-singular matrix of order n, then A into adjoint A equal to det A into I. A into adjoint A equal to det A into I. Determinant value of adjoint A equal to det A whole power n minus 1. Determinant value of adjoint A equal to det A whole power n minus 1. Determinant of adjoint A equal to det A whole power n minus 1 whole square. Next point. A into adjoint A is given by det A whole power n minus 2 into A. The matrix adjoint A is equal to det A whole power n minus 2 into A. Next, fifth one. A inverse equal to adjoint A by determinant of A. Sixth one. Determinant value of A inverse equal to 1 by determinant value of A. Determinant value of A inverse is 1 by determinant value of A. Now, I would like to explain how to calculate adjoint of A. For example, A is 3, 2, 7, 5. Now, adjoint of A is given by transpose of cofactor matrix. What is cofactor matrix? Cofactor matrix is obtained by replacing every element of A by corresponding cofactors. Now, cofactor of 3, 2, 7, 5 we have to calculate. 3 is in which place? 1/1 place. Minus 1 whole power 1 plus 1. Eliminate first row and first column. What is left? 5 is left. Therefore, minus 1 whole power 2 into 5, that is 5. Cofactor of 2. 2 is in which place? First row, second column. Eliminate first row, second column. What is left? 7 is left. Minus 1 whole cube into 7. Minus 7. Next. Cofactor of 7. 7 is in second row, first column. Eliminate second row and first column. 2 is left. That is minus 2. Cofactor of 5. Minus 1 whole power. 5 is in second row, second column. Eliminate second row, second column. 3 is left. Minus 1 whole power 4 into 3 plus 3. Plus 3. Now, the cofactor matrix is replace every element by corresponding cofactor. 5 minus 7 minus 2 3. Now adjoint of A is transpose of cofactor matrix. Take transpose of cofactor matrix. 5 minus 7 minus 2 3. Understood? So 5 minus 2 minus 7 3 is adjoint of A. Now if you would like to find A inverse, then you have to calculate det A. What is det A? 15 minus 14, 1. Therefore A inverse equal to adjoint A by det A. That is 1 by 1 of 1 by 1 of 5 minus 2 minus 7 3. That is A inverse. So in this problem, adjoint A and A inverse are equal because determinant value is 1. Understood? Tomorrow I am going to discuss problems related to basic concepts. Thank you. Yeah, I am going to complete course on engineering mathematics for XE in this course. Thank you.